I'll be talking about the fifth carpal metacarpal joint and basically its movements, classifications, osteokinematics, and it's also called the fifth CMC joint. But as we can see here, it is located at the base of the fifth metacarpal bone and the hamate. And you can see that the green portion right there is the hamate, and that is highlighted. And this right here is the fifth metacarpal. And so the proximal articulating surface would belong to the hamate right there. So we can see if it's more proximal to the body, as would all the carpal bones compared to the metacarpals. And the fifth metacarpal is the distal articulating surface where they make up that joint right there. And structurally, it's a synovial saddle joint, and that's very similar to the thumb as well. And it's going to be classified as a diarthrotic joint. It's freely movable, but it still has some hindrance through its range of motion. And we can see that by the free space over here, basically. These are very hindered, and these two are not. And so the osteokinematics of the fifth metacarpal joint just allows you to grip and cup objects in this sense. So I'm not sure if this can move. Yeah. But in that sense, it's able to cup, and that is why it has that diarthrosis classification compared to just the normal ones. It's very similar to the thumb in a sense. And it has flexion and extension and slight ab and adduction on opposite type movement as well. Its range of motions are about 15 to 20 degrees for flexion. Extension is about 10 degrees, and you can really just see that it doesn't go much, but the flexion does double about, and minimal abduction and adduction about 2 to 5 degrees as it's hindered by the scaphoid and the capitate. Yeah, so I mean, it just really makes like a power grip. And so as we can see, back here we are again with this 3D model. The base of the fifth metacarpal is convex, and it's almost holding the surface of the hamate, which is concave. And so that's really essential because it has that saddle roll, and so it is able to roll and slide on the same direction on that concave surface of the hamate. So without the hamate being able to accommodate the fifth metacarpal, we wouldn't have such movement to roll and glide. And then during extension, it rolls and glides in a dorsal direction in the same way. So it rolls and glides in the same plane back as it does whenever we're trying to grip. And it's just a beautiful representation. I'll show you the back right here. It's primarily classified as a third class lever during flexion and extension, and the axis is the CMC joint itself. It moves and rolls around that joint specifically. So muscle force is applied along the proximal phalanx. Resistance at the fingertips allow more pressure to be absorbed by that joint, which is really essential for like gripping and cupping, so that whenever that pressure is applied, it can be absorbed and dispersed, and it can also maintain strength around. And the flexor minimi and flexor carpi ulnaris both shorten and flex the wrist and the fifth carpal metacarpal joint, and that will be those muscles will run along this, and this side of the ulna. So they can really just relax and contract and move this back and forth. And extension and flexion of that is essential with these muscles. And the extensor digiti minimi may experience some passive insufficiency when it's stressed across both the wrist and the fingertip joints. And it just plays a critical role in the hand's adaptability to cup and to grip. And with its saddle type movement of rolling and gliding, it is essential for it to be specifically located with being articulated with the hamate and the fifth metacarpal, so we can rotate and roll around and have a greater ab and adduction movement than the rest. I wouldn't say it's as important as the thumb, but it is still very essential. Thank you.